The IDATA Project presents an introduction to the 24-inch model with Katya Gosman. Katya is standing behind a table with the sea green Yerkes 24-inch telescope model in her hands. She is wearing a sweater with an alpaca on it and is wearing a necklace of the constellation Lyra.
Hi everyone, my name is Katya Gosman and I'm an IDATA undergrad. And today I'm going to explain to you the model of the 24-inch Yerkes telescope that you should have gotten in your IDATA package. Tia Burtz, one of our IDATA undergrad mentors, created and 3D printed these models, and she did a fantastic job.
The camera is zoomed in on Katya's hands holding the 24-inch model.
First off, have the model in your hands. There are two parts to the model, a base with a V cutout on the bottom, and the actual telescope. A long hollow tube connected to a mount with a circular base. These two parts are connected by Velcro dots located at the bottom of the circular base and the top of the V-cut base. If you hold onto the mount of the telescope, which should just feel like a square pole with one hand, and the V-base with your other, and gently pull, the two should just come apart. Try it. Also try finding where the Velcro dots are. Play around with the model a bit, and when you're done, put the V-base and the telescope back together again. Now set the V-base with the telescope attached onto your desk. Notice there are two sides that the V-base can rest on. It doesn't matter which one you choose. For now, just pick a side and stick with it. Take a look at the actual telescope, which is just a tube, which we call the optical tube. One end of the tube is open. This is the part that we point at the night sky. The other end is closed and has a little blue circular bump in the center. This is the location of the primary mirror of the telescope. The bump itself also marks the position of the eyepiece and the camera. Light travels down the optical tube, is reflected and focused by the primary mirror, back towards the front of the telescope, where it is reflected again by a smaller secondary mirror. The secondary mirror is not shown on the model. Light that is reflected off the secondary mirror travels down the optical tube and finally through a hole in the primary mirror, where it can be detected by your eye or a CCD camera. Now, hold the telescope with one hand and rotate only the tube itself, not the entire telescope base. You are moving the telescope in declination, which is how a telescope moves north and south on the dome of the sky. Declination is like latitude, if we are talking about the Earth. Now hold the telescope tube in place and move the telescope with the base around. You should be able to hear the crinkle of the Velcro as you rotate. You are moving the telescope in right ascension, which describes the east to west motion of the telescope. Right ascension, or RA, is kind of like longitude.
Well, these are the basics of the 24-inch model. Tyler will tell you more about the telescope in his next video, and will reference the model you have in your hands now, so you can follow along.
The IDATA Project is funded by the National Science Foundation and is a collaboration between the following sponsors: Logos Consulting Group, Turk, Associated Universities Incorporated, the University of Chicago Yerkes Observatory, the University of North Carolina at Chapel Hill, and the University of Nevada at Las Vegas.
People involved in making this video: camera work and script, Kate Meredith. Narration, script, video editor, and audio description, Katya Gosman. 3D model, Tia Burtz.